Good evening to everyone here at IIT Palakkad, and good morning to Mr. Mani Iyer sir and Dr. Joy Thomas in California. This is the first of the Friendly Fundas Videocast series organized by the Friends of IIT Palakkad. They are a set of eminent alumni of the IIT system who hail from the area around Palakkad, Kerala, and this part of the country, and have taken an initiative to provide our students here with a forum to engage with eminent people from all across the world. So we are very, very thankful for all of you taking this effort. Also thank Professor Sunil Kumar for facilitating this. I'll go on with a formal introduction. Mr. Mani Iyer, he will be moderating the session from California. He is an alumnus of IIT Madras, a BTech in Electrical Engineering, and subsequently did his MS in Computer Science from the University of Wisconsin-Madison. He is a serial entrepreneur, currently the CEO of Quanzu, which is a leading provider of account-based display and retargeting solutions for mid to large B2B enterprises. Quanzu's customers include Infosys, HP, Equinix, Mobile Iron, Absolute Software, and many others. He had previously founded a software business which was acquired by Oracle and was a senior marketing and technology executive at Oracle, CA Ingress, and Microsoft. He happened to visit us a few months ago, and I hear from all the students who attended his talk here that it was very enlightening, and I think they had very, very positive things to say about that. Thank you, sir, for facilitating this. Our speaker for the evening, Dr. Joy Thomas. He grew up in Bangalore and received his BTech in Electrical Engineering from IIT Madras. He did his PhD in Electrical Engineering from Stanford University. He's currently a data scientist at Google working on API security. He joined Google when they acquired a company called Apigee in 2016. He had joined Apigee through its acquisition of Insights One, a company that he founded in 2011. Joy was also the chief scientist at Stratify since its founding and led the development of advanced text mining, clustering, and classification algorithms that form the basis of the Stratify legal discovery service. After Stratify was acquired by Iron Mountain, he became chief scientist of Iron Mountain Digital and led advanced technology development. Prior to all of this, Dr. Joy was a research staff member at the IBM TJ Watson Research Center, which is one of the primary and foremost research centers of IBM, where he made contributions to data mining and data compression algorithms. Very interestingly, he's also the author with Professor Thomas Cover of a textbook called Elements of Information Theory, which we actually use here as part of our syllabus. Dr. Lakshmi Narasimhan is here along with us, so he'll be coordinating the technical questions, and he happens to teach this course. So in fact, when we had a discussion once and we were looking at that textbook, and we were trying to find out more about the authors of this textbook, and it's really nice to see Dr. Joy Thomas in person here. Thank you, sir, for coming.
Oh, thanks.
At his stay during IBM, he was a recipient of 2 IBM Patent Awards. He's also the recipient of the IEEE Charles Liggett Fortesque Fellowship for 1984 to 85, and the IBM Graduate Fellowship for 1987 to 1990. He has been an adjunct professor at Columbia University and Stanford University. Thank you very much, both of you, for coming here, and the floor is all yours.
Thank you, Arvind, and hello, everyone. Welcome to all the students. My name is Mani Iyer. I'm going to be your host, moderator for this webinar and videocast presentation. So let me first talk about the kind of the genesis. As Professor Sunil Kumar mentioned, I was visiting Palakkad. That's when I guess I kind of picked up on it. I grew up in the Palakkad area. So of course, I was thrilled and delighted that there's now actually an IIT in Palakkad. And then when Professor Sunil Kumar was visiting the Bay Area, that's where the whole idea of this videocast series came up. Now, I think you guys might find it interesting. Why are we calling it Friendly Fundas? Why are we calling it that, right? So here's my thing. When I was a high school student, I didn't even know there was this thing called IIT. So there was some guy who was visiting a relative of his to the village in Palakkad where I did my high school. And he said, hey, I asked him, what do you do? He said, I go to school at IIT. I said, what is IIT? He said, it's one of the best engineering schools in India. So, okay. I said, how do I get in? So he said, he gave me 4 words. And he said, get your fundas straight. So that's really where, that was the first time I heard the very word called fundas. And I said, you know what? That's what you got to do. It's true for how you get into IIT. It's true for life in general. Is you got to get your fundas straight on any topic, any subject, any area. Basically, have a lifelong learning, mentality, if you will. So I'm pleased and delighted to have Joy Thomas, my good friend, and you guys probably don't know this. He was my classmate at IIT Madras, right here with us. And hopefully you will pick up a few fundas along the way from him. Believe me, he's got a lot to offer. So, Joy, welcome. And yeah, we're going to kick it off, guys, with basically going through Joy's, experiences all the way from IIT to where he's at today. That's going to be the first 20, 25 minutes. And then, of course, we're going to get into some of the Q&A. We're going to talk about specific questions that have come to us from the students. Joy will address those. And then we'll wrap up. The whole session, we are aiming for about 50 minutes. So that's our goal. So the Joy, to kick things off, can you talk about your early days getting into IIT Madras? And I'll say this. Among us, if anybody has cracked the code, first, of course, you were All India rank JE #1 in our batch. Impressive. And you clearly cracked the code on, getting your fundas straight, all the way from how you got into IIT. And I remember this, which is we would stay up till 1:30 or 2 in the morning for tests and exams and quizzes. And Joy's lights were off by 9:30 or 10 p.m. So, and he would go the next day and still ace his exams and quizzes. So give us some funda, Joy, please.
Okay, thanks, Mani. I hope you can hear me clearly. So, as Professor Arvind mentioned, I grew up in Bangalore. I went to St. Joseph's Boys High School in Bangalore. When I was going through high school, I was always interested in science. In fact, if you had asked me in high school, I thought I would become a researcher in physics. But I didn't know much about IIT when I was in high school. I had distant relatives who went to IIT, and I heard about it when I was in PUC. First year PUC was when I actually heard little more about IIT. There was this coaching class called Agarwal classes that had a postal coaching that started at that time. And that's how I learned a little bit about what JEE was about. So I took that class. In fact, they just started the previous year. And so I had some idea what the JEE questions were like. Now, JEE, this is almost 40 years ago. JEE was very different from what it's now. There were many fewer students taking the exam then than now. So JEE 1 wasn't as difficult to be now as it is now. I must say, looking at the stories of people who do JEE now, preparing for many, many years to get in, I think part of the challenge is that they miss a lot of learning in high school by spending all the time preparing for one single exam. Anyway, so being JEE 1 definitely changed my life. So when I got to IIT Madras, the expectations were very high. But on the other hand, unlike, again, what I see more recently, students had a broader range of interests. When I was at IIT Madras, one of the things that I was sort of active, I was doing some extracurricular activities. I was sort of the quiz coordinator. I used to take part in quiz contests even before IIT, but I was part of the organizing team of the quizzes at IIT. IIT Madras has this cultural festival called Mardi Gras, and actually one of my fond memories is organizing the quiz at Mardi Gras. Quiz is a big event on one of the nights at Mardi Gras, and one year we organized a high-tech version where people would type the answers simultaneously into computers and show it up on the screen. Now, this was 35 years ago, and computers were much less powerful then than now. And so it took a lot of effort to get even that thing to work. Um, Anyway, the key message I would say about my stay at IIT would be that yes, it's important to do academics, but it's also important to do other things. This is the time when you have a chance to explore the world, and you should try and make the best of that opportunity.
Thanks, Joy. I'm not sure you really answered how you cracked the funda on, acing those exams, still sleeping early, but we'll keep going.
Okay. No, there's no funda to it. It's you. I mean, if you're passionate about a subject and you learn it deeply, I think it becomes a lot easier.
Okay, fair enough. Go ahead.
No, so one thing that I would emphasize is there's a difference between knowing enough to crack an exam and knowing enough to know that you know enough. Correct? If you have, for example,
Okay.
want to teach a course, it's very different from learning the course just to write the exam. Because if you want to teach, you have to know not just what the straight path is, but also what the side paths are. And for any subject, I think when you learn something, you should try and aim to learn it deeply as opposed to just the superficial stuff.
Okay. No, that's fair. Now, can you then, Joy, talk next about from IIT, why did you choose to go to, directly into a PhD program at Stanford? Because I know a number of students have questions for us about, should I do master's, should I do PhD, academia, industry? What's your perspective on that? What was it then, and has it changed?
So clearly, at the time we graduated, the options were much fewer than they are now. Most of our graduating class either went to study abroad, went to IIMs, and actually a relatively small fraction went to jobs after IIT at that time. But so I was pretty clear. I wanted to do some kind of research. I was very interested in learning more, and curiously enough, when I was doing my undergrad, I read some of the papers, the original paper on information theory by Claude Shannon, and I was very convinced that that was what I wanted to work on. So I learned more about it, and I knew that Tom Cover, my advisor, was one of the top experts in the field at that time. I actually applied to Stanford, knowing that I would want to work with him. We actually corresponded before I joined Stanford, and in fact, one of the interesting stories Tom told me much later was he had read about Ramanujan. So I hope most of you know who Srinivas Ramanujan is, the mathematician. And there's this very interesting story about how Ramanujan wrote a letter to Professor Hardy in Cambridge, about uh, showing some mathematical results, which finally resulted in Ramanujan going to England. There's a book called The Man Who Saw Infinity and a movie of the same name that describes the story. And it's probably one of the most romantic stories in math.
Okay.
It's a very interesting thing that at that time, when we were going abroad, there were not too many Indians going to the US. And in fact, I was Tom Cover's first Indian student. And so it was interesting to hear how the faculty looked, because he had this Ramanujan story in mind when he gave me an admission.
I see.
But things have changed very much now. So one thing I would say is that unlike 30 years, 40 years ago, there are Indian students everywhere. And there's also a lot of people trying to get faculty's attention by writing to them. So And unlike then, I don't think you'll get much of a response now if you write to a faculty member. Particularly if you write an email, faculty get sort of overwhelmed with emails from prospective students, and they typically do not respond.
Interesting. So I think that's a very good key insight, Funda, for I guess the students there. Any of you who are considering, applying for graduate school, applying to schools around the world, to the U.S. Keep in mind that there's these faculty get bombarded. Same is true for LinkedIn. As many of you know, you probably are trying to build your LinkedIn professional networks connection, which is fine. A key insight there, if you will, for you guys is it's always better to go through existing connections, strong connections who know somebody, and that's more likely to get their attention. So certainly in the case of, and just a little thing, housekeeping, if you will. I'm sure even after the session, you may have questions for me, questions for Joy. Please, if you don't mind, please route them to Dr. Arvind Ajoy. That'll really help us out. And so with that, Joy, that was a good one. Really saying the students should probably think clearly about how they approach faculty at colleges and universities, wherever they want to get into, yeah, and try to get their attention in some way, more in a substantive way, in some of the things they may have done, some projects, some research, and so forth. Joy, so talk about, if you would, information theory. What drew you to it? From a technology standpoint, or really pure industry research standpoint, what are some real-world applications of information theory, and how has that area evolved since your time at Stanford? Is it still applicable today, or has it all moved on to some of the new buzzwords we hear around cloud and blockchain and you name it, right? So, give us some Funda.
Okay. As you might guess, I could talk about information theory for many, many hours. But
okay.
To start with, information theory is the mathematical theory of communication. So one of the most interesting things about information theory is that a large fraction, probably 80% of the fundamental results of information theory were present in the original paper by Claude Shannon, which was published in 1948. So Shannon was a genius who worked on multiple different fields. During World War II, he was working on cryptography. And some of the ideas actually came out of cryptography and the problem of concealing information. So the information theory is concerned about two core things. One is, how do you represent information most efficiently? And second is, how do you transmit information? How do you communicate information most efficiently? And there are two basic results. That one is that for any information source, there is a fundamental limit on the level of compression you can get, the best representation of any information source. And for a probabilistic information source, it's called the entropy. Now, that was a fairly obvious result, that you could compress information. Something like the Morse code, which was invented 100 years earlier, was a representation of the letters of the alphabet in different characters, where the most frequent letters had a short representation. So E is represented by a dot, and the rare letters are represented by a longer combination of symbols. So that was not too surprising at that time. But the second result, which is that any communication channel has a capacity which you can calculate, and that you can send information at any rate below capacity arbitrarily reliably. That was a revolutionary idea, because at that time, most people believed that the only way to send information more reliably was to use more and more power. So at that time, almost all the communication channels were analog. Examples then were the telephone or radio. And people knew that if you were far from the radio station, your signal was low, and you hear a lot of noise in the in the music or voice that you were hearing. And people believe that the only way to solve that was to have a higher power radio station or sending more power over the telephone wire. Uh, what Shannon showed is that with any communication channel, there is a capacity. And if you send information below capacity, you can recover the information at the other end absolutely reliably. So the first result of information theory shows that anything can be represented digitally at a certain rate. So you could take music, or you could take voice, or you could take text and represent it as bits. The second result shows that those bits could be sent over a channel reliably. Now, the results that Shannon proved were sort of theoretical, and particularly the second result about the communication capacity. He showed that in theory you could achieve this capacity, but for probably 30, 40 years after the original paper, those ideas could not be implemented because semiconductor technology hadn't developed enough to
Yeah.
reach those limits. But by the actually in the 60s and 70s, some of these ideas were implemented for things like space communication. But right now, the modern digital age, everything is digital, correct? I don't know whether the audience has ever heard any real analog music, because CDs, uh, even TV, HGTV, and so on, everything is sent digitally, and that is all a result of the ideas from information theory.
Wonderful. Okay, thanks, Joy. That was a great explanation of information theory. I didn't know any of this stuff, so I'm glad to learn a little bit here. Um, Now, I know from Stanford, was it your first job out of college was at IBM?
Yes.
You worked on data mining.
Mhm.
Yeah. Can you talk about that?
After I graduated from Stanford with a PhD, uh, I mean, a PhD typically has two options: either go to academia or to industry. And in industry at that time, at least, there were only a couple of big research labs, Bell Labs and IBM, that were
Yeah.
hiring PhDs, particularly international students who were PhDs. Uh, but so I chose to go to IBM, uh, or at the TJ Watson Center. I knew some of the people working there. In fact, initially I joined a group called the Speech Recognition Group that had been the pioneers in speech recognition starting in the 70s. And a lot of the ideas of speech recognition were developed in that group. But after some time, I moved to another group that did data mining and systems analysis. And I worked there on various ideas. Actually, for many years, I worked on data compression algorithms that were finally implemented on a chip to compress main memory. So I was at Watson for about 10 years. This was in the 90s. And all through that time, uh, the internet was developing, and there was a lot of activity in Silicon Valley. And while I was on the East Coast, some of my friends from Stanford who were in the Valley had planned to start a company, and they convinced me to come back to the Valley to start Stratify.
Wonderful. So yeah, that must have been an interesting change for you, Joy, from a 10 years, kind of a corporate research environment, just jumping right into a startup. What was that like?
So definitely working at IBM in the research lab was very different experience. In fact, IBM in the early 90s went through a near-death experience when they almost went bankrupt, and then Lou Gerstner joined as a CEO and decided to keep IBM together and continue to fund research. But in the early 90s, there was a chance that IBM would have died and split up into multiple companies. Uh, by the end of the 90s, IBM was much more stable, but the attraction of being in a startup was that in a big company, it takes a long time for any idea to get into practice. It took
Okay.
basically about 5 years between the time we had the original data compression idea to the time where that chip was released. Of course, building a chip takes time, but it took 2 or 3 years before the idea was approved to make it into a chip. And the key sort of advantage of a startup was that they could adapt very quickly, change things very quickly. And so what happened at Stratify is we had a bunch of very smart people from Stanford and other universities who came together with the idea of sort of doing something very revolutionary in helping people find information on the internet. So our original idea was that search engines at that time, this was around the time Google started 20 years ago. In fact, today is the 20th anniversary of Google starting.
Wow.
And but Google had not yet established itself, and search at that time was, we thought, was going to be a commodity. And there were the big search engine then was Alta Vista, but there were 4 or 5 search engines that were all pretty similar. So what Stratify started off as the idea was that instead of search, would be an organization of information on top of search. One of the ways that people looked for information at that time was using Yahoo, which was a directory at that time. It was more of a directory.
Correct.
People would navigate to the right content. So you'd have a taxonomy of, okay, there was industry, then there was computer science and computer software industry, and then there were different companies, and you'd navigate to the right website as opposed to do a search. What we started off was with the idea that we could automate that process. Yahoo was doing that by using humans to categorize content on the web, and we said we would build text mining technology to automatically classify content on the web. We soon realized that that was a very difficult problem because most websites or web home pages of websites didn't have enough content to classify. So then we focused on a particular kind of website or web pages, which were news stories, where there was enough text to classify, and we built a text classification engine that would classify all news stories on the web. The other technology that we built at Stratify was to profile users, so that the idea was not that the user would go looking, but instead we would try and understand what users wanted and proactively provide them with information. So we had this application that people ran that if you were interested in, say, in the Indian cricket team, it would show you all the content about the Indian cricket team from various sources on the web. So it was somewhat like what Google News is now, but much more personalized to you. And we launched that product about a year into the company. But as soon as we launched, it was pretty clear that our original business model would not work. We started out with the model, this was the height of the dot-com boom, where we thought advertising would solve all problems. Then we realized that in 2000, the whole business model collapsed. A lot of companies got started in the late 90s with that model and never made any money. So around the end of 2000, we shifted our model to enterprise software, where we try to take the same technology and sell it to enterprises to help people find content inside the company.
Yeah.
And that was what we did for the next few years. Again, we had some success there, but it was not a very easy sale. People often try and sell technology and by saying that, oh, if people use this technology, they'll save a few minutes a day. And you multiply the few minutes a day by the number of people in the company, and you get a large number and a large cost. Unfortunately, nobody really believes those numbers. So around 2003, we realized that that was not going to go very far, and we came close to shutting down. But then one of our investors suggested, why don't we look at the legal market? And the legal market, lawyers need to process a lot of information when they are involved in a lawsuit. In the US, they have this concept of discovery, where if you have a civil lawsuit, each side has to give the other side all the relevant documents. And the lawyers need to look through all the documents before they give it to the other side. 20, 30 years ago, it would be looking at the CEO's papers in their in their drawers. But now, when you have email and online documents, the volumes are much larger, and so this became a very difficult problem for the lawyers. Stratify developed technology to make it easier using clustering of text and classification and so on. And the lawyers really appreciated that. So Stratify did well. About in 2007, Stratify got bought by Iron Mountain, and I stayed on till 2011 as chief scientist at Iron Mountain Digital.
Okay, wonderful. So, Joy, if I can draw a little bit of insight from what you just said, and hopefully folks in the audience will catch on to this, is, guys, what Joy just said was one of the keys to Stratify succeeding was in finding a very clearly defined market niche, in this case, lawyers, and a problem for those lawyers, which is legal document discovery and information discovery, and retrieving it and organizing it. So if you, anybody in the audience, if you guys are thinking of doing your own startup, again, think about not just the technology, but the problem space where you might apply the technology, the customers, potential customers, the market where you might apply the technology. All of those dimensions have to work out for you in order for the business to succeed. Pretty obvious. And again, what's counterintuitive here is the narrower you go, the better you are. Because, you know, often you think about, hey, the market is huge, I want to go after everybody. Well, guess what? You only have a few people in your company to actually develop the market or get your brand out in front of those prospects and customers. You probably narrow down your focus, and then you'll see success. So, Joy, that was a good one. So let me now move on. And if you can talk about Insights One, which is the next company you co-founded after Iron Mountain. What was that about? And then, and I know that Insights One got acquired by Apigee, and Apigee got eventually acquired by Google. Talk about that part of your journey, and then we're going to turn it over to student Q&A.
So after I left Iron Mountain, I joined with a couple of other friends, one of whom was at Stanford with me, to start a company called Insights One. And our core idea was that there was at that time, and even now, big data was a hot term. And there were a lot of technologies that were used by the big internet companies like Google and Yahoo and others that had not gone over to the other smaller companies. So my other two co-founders were from Yahoo, and our core idea was to take some of the ideas of building predictive analytics on Hadoop and build a platform that could be used by regular enterprises, not just internet companies. So we started with that model. We were working with multiple use cases like recommendations and targeting and healthcare, finding customers who are unhappy and so on. About 2 years into the company, Apigee was in the process of going public, and they wanted a new product area. So they bought Insights One. Apigee went public in 2015 and then got bought by Google in 2016. Over the last few years, actually, my team from Insights One have shifted focus from doing the predictive analytics to doing security on APIs. So my team now focuses on trying to find threats on APIs, again, using machine learning and data science type methods.
Okay, sounds good. I think that leads right into your current role at Google. I think you started touching on that. Let's talk about current trends in technology, current areas where a lot of companies are hiring, companies are looking for talent. This should be of interest, I'm sure, to the audience here, and I'm sure the audience is hearing a lot of the buzzwords. Can you kind of peel back the layers for them? Let's talk specifically around data science. What does a day in the life of a data scientist look like? What do you do on your job day to day? That's number one. And number two, can you talk about how data science is different from data analytics or business analytics? And so if we can hit those two, and then of course I'm going to ask you about how can the audience, how can our students get started in this area? Back
Okay,
to you, Joe.
data science is actually, as you probably all have heard, is a very hot term right now, and there are lots of predictions of a big shortage of data scientists. Uh, I think Gartner or somebody said that there'll be a couple of million data scientists needed in a few years, and the actual number of data scientists in the U.S. is the order of tens of thousands. Now, unfortunately, data science is a very ill-defined term. It used to be called data mining, data statistics, uh, and now the hot term is actually shifted from data science to machine learning. But they all refer to a very broadly the notion of using data to derive insights. Uh, now, Mani asked the question of what is the difference between data science and analytics. So the classic approach was to use data to create reports, and there are a variety of tools around that, Tableau and so on, that will create reports out of large volumes of data. Data science, I would say, is more creating insights and predictive, uh, trying to predict things using the data that you have. So Google, for one, clearly is making a lot of advances based on the data they collect. Search is one, but being able to match people with ads that are most relevant to them, uh, suggesting completions on your Gmail, all those technologies are based on machine learning, which is based fundamentally on huge volumes of data.
Okay.
Now, uh, very few companies have the volume of data like Google or Facebook, but even smaller companies have a lot of data. One of the causes of the hype about data is that, or machine learning, is that companies are by default collecting large volumes of data. Collecting data is no longer expensive as it used to be a decade or two ago. So it's easy to
Yeah.
collect the data. But the challenge is how do you get value out of it? So a data scientist like me, most of our time is spent trying to understand the data, trying to figure out what is the data saying in terms of what is the normal behavior, what is abnormal, what are anomalies. So, for example, in terms of API security, there's a set of normal users of the API, and what we are trying to find is people or programs that are behaving abnormally, trying to do things that they're
Okay.
not supposed to. And
Uh,
there is uh, there are various algorithms that are available to do this, but fundamentally it comes down to understanding the data and figuring out what is normal, what is not.
Okay, so what are the building blocks for someone who wants to get into data science? It sounds like, is it statistics? Is it probability? Is it math? I mean, what somebody here in IIT in undergrad, what courses should they be really taking in and you know get it up and down, really get the insight on it to get into data science?
So I would say there are sort of two different aspects of it, right? One is there's a set of computer science related tools that you need. The
Okay,
uh, you should know some languages like R or Python that will help you build and run algorithms. And then there is a understanding of the data that comes from probability and statistics. Now,
okay,
my background, as Mani would say, is in electrical engineering, and so I was not a computer scientist by training, but having the tools from computer science is definitely very useful. But what is most critical, and I think what distinguishes a data scientist from a computer scientist, is an understanding of data. Uh, uh, the basic idea is that data is or a computer scientist tends to approach data as, oh, it's just a matter of counting things, and whereas a statistician would say that the data that you see is an example from a larger set. It's a sample of a larger set. And what you're trying to do with the data is not just count what is there, but try and derive characteristics of that underlying model. And being able to appreciate that and be able to formulate the problem correctly in that fashion is what will make a data scientist.
All right, wonderful. Thanks, Joy. So I know we only have about 15 minutes left, so I'm going to now turn it over to the student Q&A portion. 15-20 minutes. Sound good?
Okay.
So on that front, how do you want to do this, Arvind? I know we have a number of students that have submitted questions. Do we want to do that, or did you want to have live Q&A with some students?
So I think what I suggest is that Dr. Lakshmi will coordinate this question answer session. And what we've discussed is that we'll first go through the questions that have already been uploaded to the document. I see that a few students have actually uploaded multiple questions. So in the interest of time, what we'll do is that we'll invite each of those students who have already uploaded their questions and their choice to ask their most important question first. And then we can, once we do that, we'll then open the hall for any other questions that anyone might have. And if we still have time, we can go to second level questions that students had already uploaded. Would that work?
Sounds good. Absolutely.
Okay.
Absolutely. And guys, anybody we don't get to today, please be assured that there are more talks coming, more speakers coming. We'll get to your question at the next session.
Yes, thank you. So I invite Dr. Lakshmi Narasimhan, who teaches information theory and communication systems here. So thank you.
Thanks, Arvind.
Thanks, Arvind.
Thanks.
So, hi. Let me first say that it's an honor to meet the author of the book, which I used to learn and teach information theory.
Thank you.
Yeah. So let me start away with some students who are interested in asking questions. So first, I would like to call Prabal. He's a computer science student here, and he would like to ask a question. So you can just directly just sit here and just make it as concise as possible.
Okay. Hello, sir. My name is Prabal Vashish. So my question is related to machine learning side. So we know that initially there were models related to logic, first order logic, second order logic, and then came the probabilistic graphical models. And today it's more about deep learning. So what do you think, which of these models are best suited for developing advanced algorithms in today's day? And since deep learning is much talked about these days, should we just simply focus on deep learning algorithms and ignore rest other paradigms?
Okay, so definitely deep learning is getting a lot of buzz these days, but one of the key challenges with deep learning is that they require a large number of label samples. So it works well for the kind of problems that Google deals with, such as machine translation or labeling images or speech recognition, etc., where you have a large amount of data and a large amount of labeled data for that. But for most enterprise problems or smaller level problems, you don't have that level of data, and deep learning is not clear is the right answer there. There are lots of other algorithms that do well. The other big challenge with deep learning is the fact that people don't fully understand why it works. This was a problem with neural networks earlier, and deep learning is worked very well for a larger class of problems than neural networks earlier, but it's still a mystery why it doesn't work or when it doesn't work. So I would definitely say deep learning is appropriate for a large number of problems, but it's not the only answer. And there are many other algorithms for smaller problems that might be more appropriate.
Joy, can you give us some examples other than deep learning? What are these other algorithms?
So I mean, they vary from logistic regression, decision trees, support vector machines. There are, if you do a course on any of these things, you'll be introduced to a large number of different algorithms. In fact, even at Google, where there's a lot of work on deep learning, most of the actual use of machine learning is with simpler algorithms. The deep learning is used only for the algorithms that or for the problems that have a large amounts of data already.
Is there, Joy, any particular reference source or guide that you like for folks who are interested in this whole topic and area around deep learning and all these different algorithms?
So there are lots of very useful resources online, including there's the machine learning course on Coursera and so on, which gives you a good introduction to machine learning. I like some more theoretical books on classification algorithms. There's a book by Friedman and a few other authors at Stanford called Data Classification and Decision Trees. That's a useful resource. The thing is that again, one thing that I'd emphasize to the audience at IIT Palakkad is, if you go on the internet, there's a whole variety of resources. One big change from the time I was going to IIT is the fact that on the internet, we didn't have the internet when we were at IIT, and we didn't have, when I came to the US, I had almost no idea what Stanford looked like. We had a one-page description in a book in the library. Now you can actually do a 3D walkthrough of wherever you are in the world. You have a variety of information. In particular, in terms of data science, there's a site called Kaggle, which Google bought about a year ago, which has data science competitions. If you guys are interested in data science, I would highly recommend that you go there and try out some of the examples and competitions they have there. It gives you a good introduction to real world data problems, and you also get some intuition about what it takes to actually get any of these algorithms to work on real data. Real data is very different from what the theory teaches. You have to handle noise and errors and missing data and things like that. And that's the kind of experience that companies would look for.
All right, thank you, Prabal. We will now move on to the next student. Thank you.
So next would be Prasanna from EE department.
All right.
Hello, sir. So I'm Prasanna Venkatesan from the Electrical Engineering Department. I'm interested in the applications of electrical engineering in the biomedical industry. I worked with Dr. Nitish Thakur at Johns Hopkins University in a related field. I am keen on pursuing my PhD starting this fall 2019 in a related area to biomedical implants. Electrical engineering application in the biomedical field. So would you suggest me to apply for a PhD program in electrical engineering department or a completely biomedical department?
So so what I would suggest is that when you apply, you look at each of the universities and what the faculty are doing, correct? Now, most electrical engineering departments might not have very much in the biomedical field, or they might have very specific things. Like at Stanford, they had some faculty who worked on medical imaging, but I don't know whether they had anybody who worked on implants or any of that stuff. In fact, there were people in the mechanical engineering department who worked more on the implant stuff. So it's hard to say. What I think you need to do is to find faculty who are doing the stuff that you're doing, because as you mentioned, this is sort of interdisciplinary, and the faculty could be in either place, and then apply accordingly.
So I actually wanted to also do a master's in surgery. Will it be wise to go for a PhD plus master's in surgery?
So I actually don't know anything much about a master's in surgery. my impression would be that you'll never be allowed to do anything like a master's in surgery unless you do an undergrad in medicine. But I don't know. So in terms of that, you might be able to get to do some actual medical stuff, but uh, given the way the rules are in the US, it's highly unlikely that you'll be actually allowed to touch human beings without a lot of training on that.
Yeah, that is very true. I think that'll be a very difficult leap from what you're doing now. So good luck to you. All right, we're happy to talk to the next speaker.
Thank you.
Student.
Next would be Priyanshu Srivastav. He's a computer science student.
Hi, Priyanshu. How you doing?
Hi.
Good evening, sir. I wanted to ask something about startups. So it's like, when do you think one utilizes his or her potential the most, while being a part of a giant tech company or while being in a startup? I also wanted to know that if you are given a chance as a fresher as of now, so what will you choose to join and why? And is it true that established companies do not appreciate sudden paradigm shifts while newer ones are quite flexible with it?
So you're right about what you just said, that startups are much more willing to try new things, whereas established companies are uh, unwilling to change very easily. That said, so the basic question is, as a fresh graduate, would you join a startup or not? Again, there's no global answer. There are startups that are probably very attractive and worth joining, but I would hesitate to start a company myself without having some work experience. What is definitely true is that while you might learn a lot of theory at the IIT, you until you start really working at a company, you don't understand what it takes to apply the theory to a real world problem. And it is definitely very useful to do that before you start something on your own. Also, there are lots of parts of working that IITs particularly don't train you for. To actually succeed in a job, it's not just about knowing how to solve a theoretical problem. It's about communicating, working well with others. It's about organizing your time, all those things, which again, work experience is very useful. Now, I don't know how many of you get to do internships or summer jobs. That's also a useful way to see how companies actually work, which is probably very different from the image you have sitting at IIT.
So,
Yeah, so if I
thanks.
can add a couple of things, so I would say definitely I would echo what Joy said. For most people, when you're fresh out of college, I think that initial few years of work experience is tremendously valuable before you join a startup, because a startup by definition is a much more risky affair, right? Because you want to not put too much financial risk and burden on yourself and your family, and B, if you time it right, you've actually developed a lot of skills beyond what you're learning at IIT, which is academic, kind of theoretical skills, real practical workplace skills, and you become really good at some functional area. For a startup to succeed, a startup, I think of it as a very simple way, two things, right? They know how to build something that's valuable to the market, and then they know how to sell it into that market and then acquire customers. So let's say you're coming at IIT and you're coming from a technical background, you need to be a great builder of stuff, something that the company is going to take to market, and you need to be super valuable for that startup in that area. When you're a fresh engineer, chances are you're still learning, right? You're still growing. So you're better off working in a larger organization and learn and hone your craft some more, and then you might be ready for a startup in a few years. Sound good? That certainly would be my recommendation. In terms of can you join not a public company, but maybe an earlier stage company? The answer is yes. There are later stage startups that might be a good place for you to go jump in as an entry level engineer. But typically those would be companies, they probably have already scaled to several hundred employees. They're not in the thousands of employees like a Google or a Facebook, but they may be in the hundreds of employees. Maybe right in India or even in different parts of the US. I hope that helps. Thank you.
Thank you.
Thank you. Next would be Vinay from EE department.
Hello, sir.
Hello.
Hey, Vinay.
Nice meeting you, sir. I want to ask about something related to career, sir. You might have seen many Indian students switch their streams after BTech and they go on pursuing MS in different fields. What is your opinion on switching streams and what one should keep in mind while switching streams? I always wonder how people cope up with entirely new field. Would that take time, or what is your opinion? Basically, is it easy or is it very difficult?
So in terms of switching, correct? It again depends on your interest. There was another question I think about switching to computer science. Clearly, computer science is sort of the uh, base of a lot of what people do. In fact, I would guess that in our graduating class, independent from IIT Madras, independent of what they studied as a major at IIT Madras, more than half of them are working in computer science in some form or the other, including me for that matter, even though my undergraduate was in electrical engineering. At the same time, I never did a formal course on computer science. Um, so if you wanted to switch, definitely the time you graduate is a time to switch. I recognize that the way the system is organized at IITs and in India in general, you choose your major when you start based on your rank, etc. And uh, in the US, though, people choose their major while they are doing the undergrad, and they do a lot of switching during the undergrad itself. Now, when you finish your BTech, that is a point where you can switch, but it's not. It's going to be pretty hard to switch, say, from electrical engineering to metallurgy, uh, unless you've done enough coursework in material science while doing electrical engineering. Um, so there will be some options, and depending on your interest, it's worthwhile to switch if you are really interested in the other thing. Uh, Speaking of computer science in particular, yes, it is valuable to some degree to have a formal degree in computer science, but I would not say that's a requirement for doing work in computer science. What I think is most critical is that you pick up the tools. Computer science, the way I use it is a tool. It's not the theory that I'm interested in. It's the tools that I need to get my job done.
Thank you.
Yeah, a couple of things I might add on this topic is what's new for you guys that wasn't available to us is there are now online degree programs. I know about master's programs that are available in computer science and data science and data analytics at some of the top schools in the US. For example, I've heard of like a Georgia Tech program, which is a top 10 school, and it's 100% an online program. So you could be sitting anywhere around the world, including India, and get a master's degree from Georgia Tech, right? A master's in computer science while you're on a job in Bangalore, in Pune, in Chennai, still get a master's degree. And then a couple of years later, 3 years later, you're switching to a full-time career, which is a software career. This I'm saying for people who might be in other departments. Maybe they're in mechanical, maybe they're in chemical, they're in civil, and they decide they want to have a career in the tech industry, in software. Entirely doable, entirely possible. In fact, as Joy said, many of our own classmates, they've all switched into software and computer science over the years because they decided from whatever they'd done in undergrad, that's a better option for them. Okay. Good luck to you.
Thank you, sir.
Thank you. Next would be Yasin from computer science department.
Hello, sir. Sir, do you think that the field of computer science is too much revolved around data science today? Or can you list out some other trending topics in computer science, if any, as of now?
So yes, definitely data science is sort of the hottest field around in terms of computer science, but there are a lot of other areas that are pretty active. So I'm sure that you've heard about the fact that Moore's law is coming to an end. So as a consequence of that, the chips are not going to get faster and faster at the same rate or as they used to the last 30 years. And the there's a lot of paradigm shifts that are coming out of that. Basically, programming is shifted from doing everything on a single CPU to much more distributed systems. And as a side effect of that, a lot of technologies will shift. Uh, so, uh, I mean, I'm not going to be able to say exactly what will be the hottest areas in computer science going forward, but compilers, being able to do hardware design for a more distributed system. Actually, one of the interesting ideas that Google has been pushing in the last few years is something that was actually popular in the 80s. There's no notion of systolic arrays for computing. Uh, they have implemented this in what they call the TensorFlow chips that do machine learning on the chip. And while it is the ideas are based on machine learning, but it is trying to translate the machine learning ideas into hardware. That's a pretty hot area right now.
Yeah, so I might add a couple of things. You're going to have an upcoming speaker. Your next speaker will talk specifically around one other hot area. I mean, broadly being labeled as AI, right? Artificial intelligence, which currently, because of technology and computers, is now more viable than it was 30, 40 years ago. So AI is one hot area certainly in the Silicon Valley. And then your follow-on speaker will be talking about blockchain solutions, right? Blockchain is again a whole new technology area. There's a lot of activity there. He'll be talking about that. You guys, I think, will enjoy that. Of course, you've got other things like AR, virtual reality. You've got drones. You've got autonomous vehicles. You name it. There's a lot of technology trends that are underway here in the U.S. All of them have some way, shape, or form. They are around computer science. So there you go. Lots for you guys to get into. Good luck to you.
Thanks.
So I think we should probably begin the wrap up here, Lakshmi. What do you think?
Right. So yeah, there are still a lot more questions, but I guess due to time constraint, we'll wrap it up now. So I would like to end with some questions that I have. So
Sure.
I have a question. So first question would be like, you have been seeing information theory since the time of its inception and its evolution so far. So what would you say as one problem which you thought would never be solved, but then was very surprised to see was solved later?
So that's a very good question. So when I was doing my PhD, the general belief was that we would never get anywhere close to the Shannon limit in terms of communication, in terms of actual practical codes. But then in the 90s, turbo codes and later on low density parity check codes and so on showed that you could actually come very close to the Shannon capacity in a very practical way. So that was something that I didn't expect when I was graduating. Now there's still a lot of fundamental problems. My thesis was on something called network information theory, which is when you have what are the limits when you have multiple senders and receivers communicating with each other. The original information theory results were on single sender, single receiver communication. But there's a lot of unknowns still about multi-user communication, and there hasn't been as much progress on that as I hoped there would be.
So what do you think? Yeah, sorry, please continue.
So despite that, I think the other, if you ask me what was the positive thing, the thing that I feel information theory has done is the fact that information theory is now considered a critical component because everything is digital, and ideas from information theory have permeated through all of computer science and all of electrical engineering in terms of everything is now thought of at least in those terms, even if they don't use the theory explicitly.
So my other question would be,
very good.
Okay.
Oh, you had one more. Please go for it. Yeah, and then we'll wrap.
Yeah, sorry for that. Okay. So I was teaching information theory last semester, and the common feedback from students was like, there is a lot of theory and theorem proof. It went on like that. So what is, in your perspective, an ideal way of teaching information theory in a class like this?
So actually, that's a very good question. To me, the big attraction of information theory is exactly that. It's a very elegant mathematical theory. So in some ways it is a branch of mathematics as opposed to engineering. But on the other hand, the challenge is to tie it to real engineering problems, correct, and to try to practical problems like. So when I was teaching information theory, I would try and give examples of how things like the Morse code or things like uh, sending information um, to Mars as examples of how the theory applies to the practical world. So that if you think of it as purely a branch of math, engineers tend to get distracted and not particularly interested. On the other hand, of course, mathematicians appreciate the fact that this is a very elegant theory, that there is a lot of very simple, basic results that apply very generally.
Right.
Thank you.
Well, uh, thank you, Lakshmi, and thank you, Joy, and I think Arvind is joining us for the wrap up. A couple of things, Arvind, I want to say just as we wrap up. One is the student questions. I would ask if the students could go in and just remove any questions they feel have been addressed, and then we can keep the rest for kind of the upcoming session.
Sure.
We can stick to the same documents, so no more new links, no such thing that we need. And I have a moderator questions document that we'll update for our next speaker. And then let me just put up real quick as an announcement to the students. We have lined up Srinivas Narayanan, Director of Applied AI and Machine Learning from Facebook, as our next speaker on October 25th, same time. And with that, let me turn it back to you, Arvind, as we wrap up.
Sure. Thank you very much, Mr. Mani Iyer and Dr. Joy Thomas. I think the session was extremely illuminating. Thanks to all the students for attending. Thanks to Lakshmi and Dr. Jasin for helping with the arrangements from the faculty side, and Soju, Biju, and Sumesh, our ever dependable technical staff, for all the video conferencing support. So thank you very much.
And the one final note would be the recorded video cast. I'm sure, Arvind, we're going to make it available through a link on the same IIT Palakkad page.
Yeah, we'll do that.
Sounds good. Thank you all. Have a good night.
Thank you. Thank you.
Thanks a lot. Thanks for joining.
Thank you.
All right. Thanks, Joy.
Bye.
Bye.
Thank you all. You just close that. Which one? No. Let's not close. They are doing something. Let's not close.
Recording.